All right.
Sure. Okay. So I think we said in Slack that we're going to be doing these Zooms probably every other week at the moment. One of the reasons for that is there's not too many new features coming out that we can show. A lot of the work that's going on at the moment is finishing off and polishing off features that are already there, or things like documentation, which it's not really worth giving you too much of an update on that. So we're going to switch these to bi-weekly for the near future, at least. On the work that's been done at the moment, things that are complete. We've implemented the first stage of hybrid mode, and that's a hybrid mode but on a private testnet, which means that up until now, private mode only worked on a single node, and every time you generated a transaction on your signature chain, it would generate a block automatically for you on your node. The private hybrid mode allows multiple nodes to connect together on their own private chain, but still have blocks automatically generated when transactions are generated. That's the right description of private hybrid mode, right?
Yep. It's a basic permissioned architecture, which just basically means that there's name or a Genesis ID called generate, and the very first block you can configure it. Dino can give a little more color on that too. He's been doing that to kind of deploy some of his, I guess, initial demos. But essentially what it does is it's got a block signer, so it's got security properties in there so that you can essentially configure user accounts that are able to sign and create that block. And then that block then is propagated to all the nodes so that you have actual private networks that can start to form. And that's what we're doing right now to start to deploy Tritium in pre-production phases and demonstrations for some of our use cases. So that's coming along. I think we'll update the roadmap to, I guess, show that change there. We're going to be doing quite a few updates. That's the reason we're doing bi-weekly as well, is because we're kind of close to that finish line, and we're knocking out the last few sets of tasks and everything. So may try to show some more demonstrations in the coming weeks. It just depends on kind of how everything evolves. So we'll keep you guys up to date on that. But
yeah, I think off the back of that, it's worth pointing out that the demos are taking place. We're building not only demos, but we're building what's the word I'm looking for? Yeah, demo apps. I guess there's things that are being built already behind the scenes on top of our architecture in order to demonstrate scenarios to potential use cases. So there's development effort going into that is hard to show on our roadmap, and hard to explain what's being done at this stage. But yep, that's going on, and that's, as you say, that's something that Dino's been really involved in. Other little features that are happening at the moment, a fair bit of work has been done on staking in Tritium. That's now really close to completion. In fact, there's the way that staking is going to work in Tritium is a little bit different to the way it happens in UTXO. And the way it is different, and I've just had this explained to me, so bear with me. The way it is different is in the UTXO model, when you stake some coins, those coins are locked up until your stake block matures. In the Tritium model, when you stake some coins, those coins are locked up until you mine your next stake block afterwards. That right, Colin?
yeah, basically, I'll explain it like this. So part of what we were explaining earlier is like how the voting will work and everything. So we were talking about system registers. So part of the way to make that function properly is your stake. You have an object register, this is your trust account, and you have a special field in there called stake, which is unspendable. So that when you create your Genesis or you ever get a stake block, you can either choose to redeposit that directly into your stake if you want to compound the interest, or you can receive your reward directly into your balance, which means that you can spend your stake reward, but you can't actually remove the stake. until you get another stake block. And part of that purpose is to actually keep the coins locked up when you're building up trust, and also to weight the trust of the coins or the time the coins have existed in that stake, so that if you pull stake out, let's say I've been staking 10,000 coins and, you know, I have fully weighted trust. I've been doing it for a year and I want to pull out 5,000 of those coins from the stake, you're going to lose half of your trust. So that gives a strong incentive for people that put things in their stake account to keep them in the stake account, to prevent gaming the staking system. And also that helps to keep the global state in the system register, which every time you get a trust or a genesis, it updates the system register, which keeps the collective amount of stake and the collective amount of trust on the entire network, so that you can use that to reference certain, you know, how should I say it, how many coins are actually locked in. And then when you start having more voting protocols, you can compare that against that system register's values to determine what percentage has been unlocked. So those are prerequisites for the DAOs that we were speaking about earlier. And that's kind of also to help, I think, make the staking system more secure. And to keep those coins, if you're staking it, just consider it like your savings account. And you can spend your reward and not lose any trust. But if you pull that stake out, then you're going to lose trust if you create, I guess, a higher cost in moving your coins in and out of the staking account. So that we think that's going to really take the staking system to another level as well, making it a lot stronger and more resistant to being gamed. Because right now you can withdraw from your stake account and put it back in, and it doesn't really affect your trust. This way, it's going to be a lot more strict on that.
Yeah. So,
Colin?
Yep.
Yeah. One thing I would add to that is that while it's stricter about locking up your balance in your stake, it's a separate account, so you don't. The existing system stakes your entire balance automatically. Here you're going to have a choice. If you want to stake 75% of your balance, you'll be able to do that. But it'll be more strict about what, being able to take that balance out.
Yep, exactly. And so it just, you consider your stake as coins that you just want to save and earn interest off of. And then the reward going to your balance is a kind of nice little feature too, so that you can spend your rewards. So, I mean, just consider your stake account as something where you just want to spend your rewards, or you can compound the rewards themselves. And then you have a lot better control, because you'll actually have to manually move coins into your trust account before you're able to actually stake them. So you're going to have to debit and transfer them directly into that. And then that balance is going to be moved to stake, and so on and so forth. So that way you have a lot more control of your coins. You don't have to worry about having reserves or anything else like that. Cool. I guess, Paul, I'm going to mute this microphone. I think so. Okay, okay. There we go. Anyhow, Paul, yep, keep continuing.
I'm muted. Sorry, didn't realize. So the last thing to do on staking is providing an API interface into that, so that you can more easily move your coins, say from your main account into your trust account, and then to be able to specify how much you want of that to stake. So there's a little bit of work left to do in the API on that, but that's not much left. I think in a previous Zoom we spoke about an events processor, which is a utility that runs in the background that will process transactions that have come to your SIG chain. So if someone issues a credit to send some coins to you, you need to create a corresponding debit in order to put those coins into one of your account.
Debit and credit.
Oh, I did that the wrong way around. Yeah, sorry. If somebody issues a debit to send them to you, you need to do the corresponding credit to put them into your account. Similarly, if somebody transfers an asset to you, it's a two-phase thing. A transfer requires you as a recipient to issue a claim in order to claim that asset. The events processor allows you to automate some of that, so you can have it automatically claim asset transfers and automatically credit your default account for tokens, and even so far as if somebody sends you some tokens that you don't yet have an account for, you haven't manually created, we can generate you a default account as part of that. So it simplifies the process of working in this double entry accounting system to be more akin to what you might be used to working in the old UTXO model. That event processor has been worked on. It's functioning. What it's missing, and the last little bit of work to do on it, is to allow users to configure how they want it to work. Do they want to auto credit tokens but not auto claim assets, for example? You might want to do something like that. You might also want to specify a different account. So you might have it so that if somebody sends you Nexus tokens, that they go to an account called savings rather than the default account, and it's that kind of configuration that needs to be done. So we're just working on the configuration side of that. There's been some work done to the way we name assets and tokens, or rather how we name objects that are put into our registers, to introduce the concept of a namespace. And what this is for is if I create an asset called my asset and Colin creates an asset called my asset, they should both be able to exist on the network at the same time without resolving to the same register. We need to be able to allow people to create assets and tokens within the confounds of their signature chain. So this is what a namespace will do. And all that really means from sort of a user point of view is that we prefix the username in front of the asset or token name. There's a bit more that goes on behind the scenes in terms of how we hash the parts of that and build up what generates the register address, but you don't need to know about that. What this is also doing is it's setting the foundations for something we talked about in a previous Zoom, and that's this concept of vanity addresses. So if I want to create a new currency, let's call it, called ABC, I create that token on my signature chain called Paul, with the username of Paul. I don't want everyone in the world to have to refer to it as Paul : ABC, which is currently how you do it. You want the whole world to be able to reference it as just the token ABC. And that would mean it's part of our global namespace, not part of a signature chain's username namespace. We don't have the functionality to support these global namespaces yet. It's going to come in a little while, but we're setting the foundations for that. And when that happens, users will be able to register these vanity names in our global register for a fee, and we're working on what those fees should look like, and they will be fairly significant fees compared to transaction fees. You're going to need to pay a fair amount to register one of these vanity names, otherwise everyone's going to want to register them. And once you've done that,
just to add maybe a comparison before you get too deep into it, it's kind of like DNS for a blockchain.
Sure.
Where DNS is taking like a human readable word and converting it to a machine network address. This is kind of, think about a register as kind of something in the global memory of the entire network. And so this is just kind of creating that index and that mapping so that people can register these vanity names, and then they'll be updatable, like you'd be able to update a DNS entry so that you can actually purchase these vanity and sell the vanity names as well, so that you create kind of a cool economic market on that. So it's kind of like, yeah, that's just for a little bit of frame of reference, so that you guys can kind of understand a little bit more about that. Sorry.
Yep. So there's not going to be any additional fee, or at least we don't think there will, for creating assets and tokens and things inside the confines of your signature chain's namespace. But if you want to create it so that it's one of these kind of DNS entries, these vanity names, and have your asset or your token addressable via that name, then yeah, there's gonna be a much higher fee for it. We are having, just a side note, we're having a meeting next week in Phoenix. I'm over in Phoenix next week, and the dev team are having a series of meetings, but one of those meetings is to discuss the fee structures that we're going to be applying in Tritium, Tritium++, and Armin as well. And this will be one of those discussions. Our current thinking is that fees that are generated from things such as registering one of these vanity names are just going to be burnt. We're not going to use them for anything. As I say, it's going to be a relatively significant fee. Yeah, we haven't decided what it's going to be yet, but it's going to need to be high enough that it deters people from just wanting to create them for fun. It needs to be with intent. So yeah, we've put all the groundwork for that in anyway, and that's ready to go. What else is on the list? On the API side, this is where we're spending a lot of our energy at the moment, is refining and building out our API. It makes sense. It's the last thing that needs to be done once the rest of the functionality is finished. And I should say that we think every piece of functionality that's consensus critical is now done.
Almost.
Just about. You know, I've just spotted one. Yeah.
I have two or three tasks, multiple contract scripts, multiple transactions per block, which even that's not even consensus critical. Most of the multiple scripts, and then just weaving in the validation scripts. Validation script build out is done, so that's just weaving that in over the transactions. So you guys have a better context of the validation scripts. Now you have a debit and a credit. They always correspond with each other. That's for fungible tokens. Then you have a transfer and a claim for non-fungible tokens, which are assets or whatever else. And in between that transfer and claim, or debit and credit, is where your validation script exists. And that determines logic between there. So like, I'm going to debit this to you if this and this and this happen, then you're able to credit it. And that's where you do decentralized exchange. That's where you can sell an asset. That's where you can put locks on your account, you know, saying that my account can only, you know, debit so much per day or so much per hour or whatever else. So that's kind of, right now the transactions are reversible too. They're naturally reversible. So they're without validation scripts, but you put something in to say, I can reverse my transaction within 5 minutes or 10 minutes, and you can claim it back to yourself, or you can reverse it back to yourself. And then you get arbitration triangles, like I've explained earlier. And that goes in between a transfer and a claim. The arbitration exists there in order to validate that validation script to true, to either say it returns back to the sender or it goes to the recipient. So yeah, sorry, I just thought I'd drop that in, but that's pretty much it. I mean, it feels really good because a lot of the pieces are built and tested and running, and staking was another big hump, but now that's all pretty well done. And the foundation set for Tritium++ as well. I mean, we're looking pretty good.
Yep. So yeah, as I say, the main outstanding tasks that we have are around the API build out. There's some changes that need to go into our existing API that we've published that's out there. We're pretty much overhauling the design. It's not changing all that much, but we're trying to introduce consistency in our the naming of our URLs now, and the way you can use them, and also not just consistency, but trying to make them a bit more user friendly if they're used from the CLI rather than being invoked through a browser or a request that way, because people are going to be invoking some of these API calls from the CLI to access their balances and things like that. So now that we've pretty much finished doing all the layers below the API, we can see how the API needs to function in order to interact with those other layers. And there's some really cool stuff happening, especially in the assets layer, and the way that you can define assets. And that's a demo I was hoping to do this time, but I think maybe that's going to come next time. Up until now, an asset has just had a single piece of data that you could define, but now you can create assets with as many fields as you want and name them what you want, and you can define them so some fields are updatable and some aren't, and it can be really easy to use, where you just create an asset and just list off as key value pairs what all the fields are like, or you can define it via JSON or XML, or to get really complicated of what you want to define that asset to look like. There's a lot of stuff that we've done to allow the assets to be programmable in a way, and there's some other stuff coming as well to allow you to create a schema for an object register, which is an asset is an object, and use that to define other assets and things like that. So this is all coming, but this, as I say, this is why we've been putting a lot of energy into the design of the API. I think that we are really close to having the documentation finished for the API as we're going to release it with Tritium. I'll try and get that into the merging branch by the end of this week. There's not much left to do, and the documentation that we had already in there was okay, but it was not as pretty as it could be. You couldn't move between, there's no table of contents and things like that. It's been completely overhauled, so it looks a lot better than it did before. There's a lot more content in there and examples and things like that, and it now it references our new consistent naming formats and things like that. So once that API documentation is out by the end of this week, we will then proceed to implement all the changes that we've been talking about over the last couple of weeks. So yeah, the API is really where the majority of our work, I think, is left. I don't want to say how much is left. I'm not going to say how much is left on it.
I'll just give a little context. The biggest thing for a mainnet release, we need to have the consistent documentation, the consistency across the API calls. Anything API and above is not consensus critical. So what that means is when we deploy the Tritium mainnet, you're not going to be able to go and change the entire way that an object register functions unless we do a main hard fork. So our biggest focus is getting all the consensus critical things done for that. And the API is obviously going to be extended. I mean, we're going to be creating new APIs. So like Tritium version 3.1, 3.2, 3.3 are going to include a lot of that. So the API as it exists right now, we're just getting it as consistent and clear and documented as possible. But that's not anything that would hold up development. The only thing that would hold up development is making sure the consensus critical features are built, which all of the main components are now in place as far as validation scripts, object registers, signature chains, all of our core primitive objects. So yeah, I just wanted to make that clear to everybody that the API is going to be an ongoing development. And obviously we're going to want to get feedback from developers, and, we'll be able to expand out and say, hey, I want this endpoint and requests. And the API is super modular, so it's really easy to just add more functionality to it very quickly. And a lot of the under the API layer, like the operations register and ledger layer, the API, when it comes out, is probably not going to give you access to all of that, but that doesn't mean that the underlayers aren't capable of it. Because we've created a programming language, basically multiple types of programming languages, like object registers are their own programming language, validation scripts are their own programming language. It's all register based. So the API is basically writing these programs as an API call that just makes it happen pretty quickly. So it's really extensible and easy to change as we go forward without needing to upgrade the entire network for that.
Yep. Just looking through our task list that we've got, our internal task list, to see if there's anything significant that's worth sharing. And it's not. Most of it is around the API stuff now. Finishing hybrid mode.
Yes, hybrid, we're pretty close to, we'll have the roadmap updated. I mean, we're pretty well functioning in a private mode. Now, private mode is just like a permissioned signed network. If you want something more semi-permissioned, for either hybrid mode or a sister network or something like that, it'll most likely be proof of stake orientated, so that to deploy a private enterprise network, you generate, let's say, 1 million of your native tokens and then distribute 250,000 to 4 validators. And then from there, the validators can share tokens more to add more validators to the consensus so that it can become as decentralized as they wish it to be. But private mode right now exists as just like a simple permission signable consensus mechanism. And then, they'll obviously have proof of stake. And so the native, ledger layer already supports injecting hashes directly in without even having to have access to a signature chain. Since we're basically just having an enumerated byte saying 0, 1, or 2 or whatever, this hash is a legacy transaction, this hash is a Tritium transaction, or this is a hybrid block hash, which means the network doesn't have to do any processing for that data. It doesn't have to verify any signatures, so it really doesn't add any load to the network at all. It only adds another 64 bytes. But on the hybrid side, that network is therefore using that public network to say, okay, well, we know that these blocks are valid if they've been injected into the main public blockchain. It's kind of like checkpoints, I guess you could say, of sorts. So the public network is pretty much capable of it right now. The private network consensus mechanism is working as it should, and then that's going to be improved through the proof of stake. And then there's just a little bit of adding some beef in there. So the hybrid mode isn't, how should I say it? The only thing that's necessary for a mainnet activation with hybrid mode is to be able to inject the hashes into the public network. Anything more than that isn't really, it's more beef that needs to be done on the private network side of things, more development on that, which that can be done completely independent of the public mainnet release. So I just wanted to make that clear that hybrid mode is kind of for enterprise use or sister networks or things such as that, where you can just deploy your own blockchain. And we think, I mean, we spent a long time, obviously you guys know CoinShield, right? We spent a long time figuring out, well, how do we stop these scams? And how do we stop people from cloning code? Well, I think the best thing is, why don't we stop the irresponsible cloning of that, where anybody can just deploy a Nexus and it automatically generates a new Genesis block, but then it uses the Nexus blockchain to secure itself from it. So that way more people can utilize the technology, and it's still going to be Nexus. It's just because it's going to be Nexus, a nexus of Nexuses, I guess, if we want to call that. So yeah, I just wanted to kind of express that so you guys can see a little bit more of that longer term version too. And these, I mean, applications can originally be hosted on the public network, but they can eventually deploy into their own sister network or hybrid network. If you read the newest Nexus ecosystem article, we kind of explain how that's how that is.
Yeah, and again, in terms of the fees to do that, I mean, we've already said that we want simple debits and credits to be fee-free, but for a hybrid network where you've got a separate network that wants to send those hybrid blocks into the main chain, there's going to be a fee for that, and you know, we still need to determine what that fee is going to be, and that's the discussion we're going to have next week.
The fees are going to be mainly for main network stuff. The hybrid network doesn't really have a huge demand for it, but I mean, certain applications that they want to do things on the public network are going to be fee oriented, like creating a token, creating a vanity name, things such as that. And then that also creates a bit of a backing or a cost to create that token too. So hopefully that'll deter our ICO dilemma that we see with people. So, I mean, I see a lot of enterprise use cases are probably going to want to deploy a token on the public main network. And then that token can kind of be something that they use, their hybrid network uses, as far as like you're a token holder on the public network, then that therefore gives you rights on this private network. So that's kind of what hybrid means, is you use a bit of both. So there are some fees incurred on it, not necessarily just the injecting of the hash. That's just a hash, and there's no processing requirements on that. It's literally just 64 extra bytes. It needs to be included in the block. So I just wanted to make that pretty clear that, yeah, that's kind of the schematics and how we're working in that. Being the fees burnt also helps improve the economics of the system, because more use of it increases the demand, and it also reduces the supply, rather than in a case if it went to miners usually dump. So, you know, increase the demand, but then it just gets dumped right away. So it's kind of a one-to-one mapping. This way, the more use of the network will actually create higher levels of scarcity in the actual Nexus cryptocurrency token.
Yep.
We have Dino give a little update if he's willing to. I think I saw him on this. If you'd like to, Dino, you can.
Yeah, sure. I've been spending my time testing the private network, as Colin and Paul have been talking about. I've set up a 4-node network, and I'm running some applications on 2 of the 4 nodes, and making sure that transactions are created and being validated by the multi-node private mode thing that Colin just referred to. What I'm planning on doing the rest of the week is try to load up, I'm going to first load up 1,000 transactions, then go to 10,000 transactions and see how it performs, make sure all the confirmation and block validation stuff is working. And let's see the effect of the application performance based on, since the applications are also running on the nodes that are Nexus nodes. I want to see the impact on the applications. The 4 nodes are running over a Lisp overlay, so all the connections that are between the 4 nodes are done with EIDs. The 2 applications are running as client nodes, and the other 2 nodes are being run as seed nodes. So as you want to add more client nodes, they can automatically connect to well-known EIDs of the seed nodes. That's pretty much it. For the mapping system, the 2 seed nodes are acting as the mapping system. We're using the latest Lisp decent pull-based model that Colin and I have been working on through the IETF. It's working fairly well. I've had no issues with it. Using all DNS-based ways of hashing to register different types of EIDs to load split the nodes across the 2. As we scale up, we'll have a cluster of those where we can widen it and shard the EID space more so. But those are the sorts of things. So my main focus is a holistic way of deploying private blockchains with building our own applications, running the Nexus daemon, and running it over Lisp. Questions?
Yeah, I guess this is I mean, we're pretty clear on. That's pretty much the list. I guess we open up.
There was only other thing I wanted to add from the list was on the GUI front, where we're at with that.
So the GUI's been done. It's in staging. I've been chatting with the security analysts. So they estimated 2 to 3 weeks for the security audit to be complete. It could be faster. It could be slower. We'll keep you guys in the loop on that. The module market is functioning. As far as I understand, they've been writing a couple applications for it just to test out how things work. To make sure, as a developer, from a developer standpoint, what works and what doesn't work, and what's important to include and security precautions on that. So the one that we have right now, I think, already has the module market or the module functionality implemented in it, so developers can start actually developing modules and deploying them into it. And then, so that's the first iteration. As we were saying, the first iteration of Tritium that's coming out over the next 2 or 3 weeks, depending on the security audit, is the Tritium Legacy Mode and the Tritium Wallet, which we've spoken features instant load time, really quick sync times. Jack and me at least get, 45 minutes to 50 minutes syncing from scratch. And then wallet stability, database stability, et cetera, so that we don't have all the nuances of the previous wallet. And then next is the Tritium mainnet, and then next after that is Tritium++. So the Tritium mainnet is going to include a newer wallet version with more functionality in the actual implementation of the modules, and then also some basic Tritium modules as well, such as your login page, and your overview page, and things such as that. So that's pretty much where that is. This been pretty much sitting on the staging ground since end of April. So all of that's pretty much wrapped up and good to go. It's just doing our, crossing our T's and dotting our I's to make sure that we have everything thoroughly investigated. And as always, we welcome anybody else. If you want to assess the code, it's on the staging branch. And if you find any flaws or anything that we should be aware of, just let us know. It's all open. So we want as many eyes on that as possible. And we're also looking into other third-party auditors through our partnership with the Israel Tech Alliance, which is a partnership Brian Benna has forged for us. They have a lot of different cybersecurity guys too, so we might be able to help get additional audits going on as well. And we want the auditing process to be ongoing, but we just want to make sure that we do our due diligence for the first before we actually release the final product as far as the first Tritium. I think that's pretty much covers everything as we are right now. So I guess we'll open it up to questions. Questions, comments, suggestions, anything else for the last, 5 or 10 minutes. Feel free to drop them in the chat, or you can unmute yourself if you'd like it to be more interactive. Let us know if you have any questions you'd like us to answer. Well, it doesn't look like we have any questions. That's good. I think, we've been doing our best to be as transparent as possible on development, roadmaps, create better ideas. This Zoom we did slightly different with going over more specific tasks, a little bit more granular. So if there's any additional feedback you guys have, feel free to drop us links in Slack, Telegram. And I guess if there's no questions, I guess we can conclude this week's or this bi-week's Zoom. We're going to keep it bi-weekly, as Paul said in the beginning. until we get to the mainnet, just to save time. Wednesdays are usually harder days to get code done because there are call days. So, yep, I guess until next time, guys, unless there's no other additional questions.
No, it looks like everything.
Cool. Well, thank you guys very much, and we look forward to speaking with you, I think, towards the end of May. All right.
Thanks, guys.
Thank you.